The Royal Horticultural Society's new learning centre and library at Harlow Carr Gardens in Harrogate has been designed to have minimal impact on both the gardens and the environment. Awarded grant funding from the Department of Energy and Climate Change's Low Carbon Buildings programme, it'll be a flagship development demonstrating just what can be achieved by responsible planning and design. With a range of low-carbon technologies, it'll save around 15 tonnes of carbon dioxide a year. That's equivalent to the total energy demands of 3 houses. The building will exploit the surrounding landscape and take advantage of passive heating and cooling. The facade will be open to the south, and the north side of the building will be partially buried in the slope of the site. Areas of solar shading will be used to prevent overheating. During the day in the winter, the building will store heat from the sun as well as that generated by its occupants. High thermal mass and a super-insulated fabric mean it will retain heat overnight. In summertime, this will work in reverse, storing the cool of the night and discharging it in the heat of the day. During warmer periods, the building control system will actuate free cooling by opening windows and dampers. The natural ventilation system is driven by the prevailing wind and buoyancy effects. Windows will open automatically whenever the internal temperature exceeds 22 Celsius or when monitored carbon dioxide levels become too high. Occupants will also be able to open the windows manually. Ventilation will be boosted by a mixed-mode system. As carbon dioxide levels rise, purpose-built passive air expel air units will allow in cool air. If this doesn't reduce the carbon dioxide levels, a fan will boost the flow. The windows and passive air units will be controlled by the building management system. The building's sedum roof not only provides low-maintenance insulation, it also promotes biodiversity. The fabric will be super-insulated and constructed from recycled aggregate concrete blocks, timber and unfired clay bricks. There'll be 300 mm of Kingspan insulation board in the roof and 250 mm of mineral wool insulation in the walls. The floors will contain 200 mm of polystyrene and the windows will be triple glazed. The building is designed to achieve an air tightness level which is less than a third of the current building regulations. Underfloor heating will evenly distribute warmth, while the expel air units also contain heater batteries to avoid cold drafts during winter. A 22 kilowatt ground source heat pump will provide the main space heating. It will circulate a mixture of water and antifreeze through vertical pipes in the ground. This will absorb heat before transferring it into the building's underfloor heating pipes. To ensure that only areas in use are heated, the building will be separated into 14 zones. Each zone will be served from a nearby underfloor heating manifold and controlled by the building management system. Demand for hot water isn't high, but what is needed will be provided by a mix of solar thermal, ground source heating and an electric immersion. Up to 60% of the hot water will be heated by 8 square metres of evacuated tube solar collectors. The use of mains cold water will be monitored and controlled via the building management system. When the building is unoccupied, solenoid valves linked to movement sensors will isolate supplies to toilets and sinks. Cold water for toilet flushing and plant irrigation will come from rainwater collected from the copper roof. The collected rainwater will be stored in a large tank and could provide up to 30 days of supply. An ultraviolet filter will be installed to ensure guidelines for using rainwater in public areas are met. The building has been designed to encourage the use of natural daylight. This means many well-placed windows and sun pipes installed in areas like corridors. All lights will be either low-energy fluorescence or discharge. Fluorescent lamps will include high-frequency control gear for efficiency, dimming and occupant well-being. Daylight and movement sensors will also control the lighting automatically. The building's electricity will be reduced wherever possible, with the remaining requirements supplied by wind turbine. Building services, together with the renewable energy technologies, will be controlled and automatically managed by the Building Energy Management System. The system will also allow building users to see live energy generation and consumption data on a public display. This design uses every trick to reduce energy need to a minimum by orientation, daylighting, energy efficiency technologies and a high level of control. The building's energy needs will be covered by the heat pump, solar panels and wind turbine. With the emphasis on maximising the use of existing natural resources and minimising the impact on the environment, Harlow Carr's new learning centre and library will be an exemplar of sustainable development while demonstrating a zero carbon footprint.